Welcome to Objective 5.2 in the CompTIA IT Fundamentals. This lesson covers database structures. This objective covers how databases are organized and their structure. A database can be used for customer, product, and vendor data, student, courses, and grades data, employee, payroll, and benefits data, restaurant, menu, and inventory data. Every database is unique in its structure and organization. We will cover the following topics in this lesson. And if you're curious, this little cylinder symbol or icon usually represents a database. And they use a cylinder icon like this because a long time ago, the first databases used platters or hard drive platters that look something like this. So, anyway, this is kind of the universal symbol for a database. These are the topics we will cover in this lesson. First up, structured versus semi structured versus non structured. Structured data is organized in a highly predictable format. Schema defines the structure of the data. Examples: databases, spreadsheets, and CSV files. These are all structured data. Structured data is easy to search. Semi-structured data does not conform to the rigid structure of databases, but still has some level of organization. Examples: email messages. These include sender, subject, body, and signature. Or a web page. These have headers, menu, body, and images. And these are examples of semi-structured data. Non-structured data, also known as unstructured data. This lacks any structure or organization. These are easier to create. Examples: Word documents, PowerPoint presentations, social media posts, images, videos, audio recordings. Next up, relational databases. A relational database is a type of database that organizes data into tables, which consist of rows and columns. In a relational database, there are relationships between tables. Here we can see we have a customer table and a product table. In this relational database, there is a relationship between customers and products. For example, Jack Johnson purchased speakers and an office chair. This is the relationship between our tables. Next, schema. Schema is how the database is organized. A schema defines the structure of the database, including tables, fields, relationships, and constraints. For our example database, we have two tables. Each table has three fields or columns. The customer table has a relationship with the product table. The fields have constraints. A dollar amount must be entered into the price field, for example. And again, here we see Jack Johnson bought speakers and an office chair. This is the relationship between our two tables in our relational database. Also, you can see speakers. They were bought by both Yvette Ramirez and Jack Johnson. So it goes both ways, from customer to product and from product to customer. Tables. Data in relational databases is organized into tables. Tables are lists of data organized as rows and columns. Here we have a table with customer data. Each row is a customer. The columns contain different pieces of data for each customer. Here we have Tori Spellman. This is the customer ID column. And now we have rows and records. Rows or records represent one entry in the database table. For example, the row containing Tori Spellman represents one customer in our customer table. Fields and columns. A field or column represents attributes or properties of the data stored in a table. Fields and columns can contain name, age, address, phone number. In our customer table, the middle column contains the customer ID attribute. Next, primary key. A primary key uniquely identifies each record in a table. An example would be customer ID in our table of customers. There is only one primary key per customer, and it uniquely identifies them. Name would not be a good choice for primary key because there could be multiple customers with the same name. Foreign key. A foreign key establishes a relationship between two tables by referencing the primary key of another table. A foreign key is a primary key in another table that is included in this table as a field. And don't worry, we're going to go through a long example here in a second. This is the relationship in a relational database. The tables are related in this way. Both primary keys and foreign keys are unique. In our customer product database, the relationship is that customers purchase products, or products are purchased by customers. That's the relationship. Here you see the primary keys highlighted for each table. For the top customer table, customer ID is the primary key. And for the bottom product table, product ID is the primary key. Here you see how these two tables are related. A customer in the customer table purchases products from the product table. We use foreign keys to make the relationship between tables clear. So here I've added an additional column to each table, which represents the foreign key. So in the top table for customers, you have your primary key, which is the customer ID. But you also have a foreign key, which is the product ID for each customer. In the bottom product table, you have your primary key, which is your product ID. But you also have a foreign key, which is the customer ID for customers which have purchased products. And so you can see how each table has a primary key and a foreign key. And these foreign keys, they link the two tables together. Let's look at a single record. The customer Jack Johnson, purchased two products. The product IDs for the two products are 1004 and 1006. These are the foreign keys. If we look at the product table, 1004 and 1006 are the primary keys for speakers and office chair. So you see how foreign keys in one table are the primary keys in another table. Let's do the same thing for a single record in the product table. Looking at the record for television, we see that the foreign keys are 1564 and 3455. These foreign keys are primary keys in the customer table for customers Bob Bennett and Will Jones. So you can see the relationship between our two tables in this relational database. We use foreign keys to make the relationship between the tables clear. The primary key and foreign keys are switched depending on which table we are looking at. The product ID is the foreign key in the customer table. The customer ID is the foreign key in the product table. Constraints. Constraints are rules that apply to columns, fields, and attributes. Examples. An age column must be a number greater than 18. A primary key column must be unique. Phone number columns must be of the following format. A field cannot be blank. These are all examples of constraints. Non-relational databases. There are no relationships linking the data. And there are two types. Key value databases. Data is stored as a key value pair in this database. For example, name and age. Name, John Doe, age 19. Each key is unique and has a value. There is also a document database. A website is an example of a document database. Each web page is a document in this document database. Within each web page, there is data written as HTML code. And this concludes all topics for this objective. I will see you in the next lesson.